Okay, thanks, Nathan. Hello, everyone. So, as just said, I will return to the field measurements that are very useful for initial screening of drillings on the presence of possible soil contamination. So, the following detection methods, I will try and find the pointer first, sorry. So, the following detection methods and screening techniques will be discussed: oil detection pan, the soil dye test, the use of handheld PID meters, and handheld XRF. So let's start with the oil water testing. Or the oil detection pan is a rapid screening method used for the determination of the presence of light pure product, also called LNAPL, in soil. Furthermore, it's not only used to detect it, but also to delineate LNAPL zones. And it's an alternative to older observations, which may not be active, but okay, you can always have passive older observations. So what do you need for an oil water test? You can buy an oil water detection pan, as indicated here. You can also use glass Petri dishes or plastic lids. However, the latter is not really preferred because they are not always easy to clean, and then you can get false positives. And of course, you need a soil sample. So how do you have to carry out the oil water testing? If possible, you have to place the oil detection pan or the Petri lids horizontally. And when you use an oil detection pan, you have to add to both compartments to about 250 milliliter of water. Then you bring about 100 grams of soil into the compartment here on the top without an anti-reflective coating. After, you need time, or you give time for the soil to come in contact with the water. And then you can try and see if you assess a floating layer. Sometimes it's not that easy to observe it. And then you can run or some liquid over, let's say, the bridge here to the other compartment with the reflection layer or the anti-reflection layer. And there, the separation, if LNAPL is present, is most of the time more visible. Afterwards, of course, you have to clean it thoroughly for each use. So here, I don't know if you see it well. Here you see those kind of rainbow pattern indicating the presence of LNAPLs. On the right-hand side, you don't see anything, so it will be negative. But of course, be aware that false positives are possible because of the presence of oil from biogenic or origin, but also false negatives, especially when the concentration is, or when the LNAPL is not that high, or is then false negatives are also possible. What is the soil dye test? The soil dye test is a color test, is a rapid test for the identification of the presence of LNAPL or DNAPL pure product in the soil. To identify LNAPL, oil red is used. For DNAPL, the product Sudan red is taken. But be careful when using Sudan red. Sudan red has toxic properties, and especially on the field when there is wind and so on, there is a risk of subsequent inhalation. So it's recommended to perform this test in the lab as possible. But as you can see here, also commercial kits are available. And the two figures just illustrate the difference between the L-NAPL, the floating layer, when using oil red, and here the colorizing of D-NAPL, which sags down to the bottom of the glass and tube. It's easy to perform it. You just have to bring contaminated soil. It's more on the field. It's easy to put it in a bag. Add just a little bit, a pinch of oil red or Sudan red, if in case of D-NAPL. Moisten it a little bit if necessary, and then when there is a pure product present, you will observe a bright red coloring. Of course, sometimes also false negatives are possible. So here we just put Sudan red in a plastic bag. We wait several days, and you see that also some products of the plastic bag will give rise to red coloring. Those two pictures at the bottom, sorry, they give a clear indication of the presence of pure product. And here it's also only the plastic, but yeah, perhaps it's not so clear from the picture. But when you have a look to the soil, then you don't see color popping up. PID measurements. A photoionization detector can be used for soil measurements, especially for detecting volatile organic carbons, like hydrocarbons, solvents, or other contaminants. PIDs works by ionizing these compounds with ultraviolet light, which produce, so by ionizing the compounds in the soil, and then ions are produced that enables detectors to estimate contaminant concentrations. Of course, it's important that you calibrate the PID according to the manufacturer's instruction, and therefore you have to use a known calibration gas to set the baseline. You have to select an appropriate PID with an ionization potential that is applicable for the components that you want to detect. So note that bulbs with an ionization potential of 11.2 electron volt have only, or the lifetime is limited with respect to the bulbs of with an ionization potential of 10.6 electron volts. This method is non-destructive. You also, how does it work? You also collect samples in a clean, airtight bags to detect vapors from the soil directly. Why it's better to use bags? When you use jars and at the moment you close it, you put the lid on, then it's possible that false air can be incorporated in the sample. So you use a plastic bag. You bring also around 100 grams soil into the plastic bag. You close it very well, and you see, I don't know whether you can see it. Here is the tube from the PID meter. Especially when it's more clayey or silty soil, you have to handle it. You have to shake it a bit to release the vapor, and then you can measure the volatile organic carbons if present. Of course, this is just a semi-quantitative measurement, so it's not possible to really quantify individuals' parameters. So here you see three figures, graphs showing PID measurements in a soil containing chlorinated aliphatic hydrocarbons. The observations, the concentrations are results from the chemical analysis. Here we see a color dye test, and if you see well, you can here observe a red color. And indeed, the high PID measurements correspond to high tetrachlorinated ethylenes with a concentration of about 4,670 milligrams in the dry soil. So you see, it's very interesting to use it on the field and then to take specific samples which you want to have analyzed. Of course, when you carry out field measurements for L-NAPLs or D-NAPLs, it's also important when you draft the borehole profile to not only indicate lithological descriptions, but also to add, for instance, the reaction of oil water testing, to describe the visuals. If you have a passive smell, also add it in the column. And here, okay, it's not indicated. You can also add then a column for the PID measurements for the color tests with Sudan red or oil red. And then the last is the handheld XRF. This is very useful. It's a non-destructive device, which is portable, and you can measure several elements on site. So the handheld XRF detects a wide range of elements, including metals and heavy metals, in both soil and also in materials. So it's important that on-site limited or even no sample pre-treatment is required. What I forgot to mention with respect to the field measurements related to the L-NAPLs and the D-NAPLs, don't rely on one field measurement, but put all information regarding concentration data, regarding dye testing, regarding PID measurements, and eventually also the soil water test, put them all together to interpret or to evaluate whether you are dealing with a pure product or not. So that was briefly the use of field measurements, which really can help you on site to select the most appropriate samples for analysis, or to indicate the presence of pure product and to delineate the pure product zone. So I don't know whether you have questions concerning these methods. In principle, I don't know if we can illustrate them all, but normally we foresee to illustrate these measurements also during the practical exercise on the field.
Thanks. I think one of the most common ways of field screening for hydrocarbons you're not allowed to do, but everybody does it anyway, is just to smell the soil. Even though I probably end up with some sort of lung cancer from all of the benzene it tends to be one of the simplest and easiest ways to figure out if soil is contaminated, but probably not the best from a health and safety perspective.
Then you know whether soil is contaminated, but you don't know whether it's pure product or not. Especially when gas oil is smelling a lot. Diesel or is a bit more difficult. But then, okay, you know mineral oil is present, but you don't know if it's pure product or not. So
that's true. And then I guess the whole point of field screening is, ideally, you can spend less money on analysis because you only analyze the samples that are, say, positive for the field screening. And then if you have a good characterization of the soil, you can extrapolate that data backwards to some of the samples that you haven't analyzed, I suppose, depending on the parameter.
Yeah, that's correct.
Cool. Any other questions? I don't see anything in the chat. XRF, does it work? It doesn't work with water, does it? I've never actually.
Excuse me? It doesn't
XRF,
work for?
does it work with water? Can you use water samples? You said materials, so
yeah, I don't think no water samples not, but like I think Normally, if Christophe would be here, they did the research on the handheld XRF. But I think scrapnels and so on, you can use, you can try and measure. It's also a semi-quantitative result, I guess. Of course, qualitative result, but also semi-quantitative. I think, but water, I'm not sure. I don't think so. No.
Yeah,
Well,
I've never heard
yeah.
of it.
Hi, Nathan, Ilse. I follow on the back.
He's there.
No,
He's here.
you can actually measure water, but the problem is that it's really not sensitive. So you're like in the ppm range, and even more. So I mean,
Okay.
and for most of the elements in that you want to analyze, especially in groundwater or so, the concentration have to be really high in order to detect it. So therefore, for soil, it's much forward. But as you said, Ilse, we will give a demo as well on the DXRF on the soil samples, so that you get acquainted on what's possible when the practical training will go on. Yeah.
And I think somebody had just recently asked me about XRF on one of our projects. And the reason it's semi-quantitative is because like moisture content, soil texture, there's different factors that can influence the results, or what causes, why is it semi-quantitative?
I think they call it semi-quantitative because it's indeed some kind of a black box, if you would call it, related to calibration. So the calibration is done by all kind of fundamental correction factors, introducing reference samples. So in contrast to other techniques where you have, like, most of the time a calibration line and then you compare your results, with the XRF you get a result, and yeah, you have a little bit more uncertainty, but nevertheless, I think with the latest developments and software, you can make your own calibration and upgrade them. And I must admit that especially for many elements, you really get nowadays with the commercial instruments already very good indication. So I would even go maybe to even quantitative, but nevertheless, you're correct that it will still always, you have to be very careful when interpreting the data. That's true, Nathan. Yeah.
So I imagine if you had, like, I don't know, a huge site where it was cost effective, you could calibrate it to your soils in Flanders or wherever you guys were working and get some very close to quantitative results.
Yeah, definitely. I'm quite convinced that this is really possible. And indeed, for on-site, if you want to have a look, okay, what would be the best sample? I think you can go very far. But indeed, we will give some training on that and show you what's possible, as we have on some of the soil samples made the comparison with ICP. We have a benchtop XRF. Because that's also, I mean, there is still a difference between a benchtop XRF and a portable. And I have also noticed that, as always, the sample pretreatment is very important. So if you measure directly on a soil, or you, for example, dry it a little bit, grind it, also this will influence the results so that's also a very important factor to consider.
Yeah, that makes sense. You have to process it a little bit, so at least it's all the same structure size and particle size and moisture content.
Yes.
Okay, any more questions about field screening or XRF stuff? All right, so now we can move on to groundwater sampling.
Yeah.
Monitoring and sampling, or just sampling?
Groundwater sampling. Yeah.
Okay.
Okay. So thank you very much. So now we can move from soil sampling, let's say, to the art of groundwater sampling. I have quite a lot of slides, so probably I will have to skip some of them, but then, okay, you can read them at home. And if questions, you can always send a mail. I also made some corrections. So after the presentation, I will get or upload a newer version of this presentation. So what's the content of today? We will successively address the concepts of groundwater sampling, good practices and pitfalls in conventional groundwater sampling, the application of passive samplers, flux measurements, and insights into oil recovery tests. And As for soil sampling, also for groundwater sampling, accurate sampling is critical for obtaining representative data for agricultural, environmental, or construction purposes. So, as only a limited number of samples is selected for analysis, these samples must, of course, be sufficiently representative. So, although in the previous modules you have already been guided through the different building elements of a groundwater system, I feel free of briefly reframing a few key elements. And one of the main elements is groundwater, which is defined as the water present in the underground pores of soil and in the cracks and fractures of rock formations. Groundwater is stored in underground layers called aquifers, and it moves slowly through the different geological formations. Groundwater mainly originates from precipitation and melted snow. It's also an important source. Sorry, I have some problems with pointer here. It's an important source of fresh water used for drinking, irrigation, and industrial uses, and plays a critical role in maintaining ecosystems and water supplies. What's an aquifer? Here indicated on the figure. It's a layer consisting of a rock, clay, or other sediment that restricts the flow of groundwater. Aquifers act as barriers or semi-barriers to groundwater movement, thus protecting underlying aquifers from downward migration of pollutants. Why do we need monitoring wells with respect to groundwater sampling? So they are essential to evaluate groundwater flow, water quality, and water quantity. When talking about soil sampling, and leaching, the importance of groundwater research in Ukraine should also be highlighted, and we also have discussed it before. So here, a groundwater vulnerability map of Ukraine is shown on the left-hand side, and the distribution of environmental relevant incidents on the right-hand side. So with these two, I want to illustrate the critical relationship between these two maps. So the groundwater vulnerability maps, they identify regions where aquifers are more susceptible to contamination due to factors like soil composition, depth to the water table, and permeability. Military activities such as bombings, the use of heavy machinery, and storage or accidental spillage of fuel and chemicals can pose a substantial risk to groundwater, particularly in vulnerable areas. So groundwater vulnerability maps allow for targeted risk assessment by identifying regions where aquifers are highly susceptible to contamination. So these maps can be used to identify where military incidents may have a higher likelihood of contaminating groundwater, impacting both human health, food security, and also ecological systems. So the risk of groundwater contamination does not only occur in residential or industrial areas in relation to single point pollution or targeted attacks, but also in regions with agricultural land affected by the bombings. So the lower left figure shows an image of an area devastated by bombings, while the upper right figure illustrates areas with high risk of heavy metal infiltration. And based on this information, among others, the conceptual site model and thus the groundwater sampling strategy can be developed and focus, for instance, on those areas where there is a higher risk of the infiltration of pollutants. So that was in fact, the introduction of the importance of groundwater sampling and groundwater monitoring campaigns. So now we are going to the concept of groundwater sampling. At first, the design of groundwater sampling strategies and the characteristics of groundwater monitoring wells are function of the research objectives. And hereby, a distinction is made between the characterization of the water quality of an aquifer, delineation of a groundwater plume, the identification of the presence of pure product, and the performance of oil recovery tests. Today, we will not discuss the evaluation of groundwater, of water quantity. So I don't know how familiar you are with groundwater sampling. Therefore, I would like to illustrate or explain what is meant with a monitoring well. So a monitoring well is a specially constructed well used to monitor groundwater levels, to monitor groundwater movement, and to monitor groundwater quality. And they can also be used to detect the presence of pure product, L-NAPL and D-NAPL. So monitoring wells consist of a plastic or stainless steel tubes from which, and you can see it here, the lower part is perforated. This part, the filter, I don't know whether it's the correct English terminology or the screen, allows the groundwater to flow into the tube, into the monitoring well. The non-perforated part, here indicated on the figure, it's called the blind tube or riser tube. A distinction can be made with permanent monitoring wells and temporary monitoring wells. And permanent monitoring wells, also temporary monitoring wells, you can make a distinction between wells with a filter intersecting the groundwater table or with a filter non-intersecting the groundwater table. As we can see here, the groundwater table is higher or is above the screen segment, the filter of the monitoring well. So why we use permanent monitoring wells? Permanent monitoring wells are designed for long-term monitoring and the sampling of groundwater over longer time periods. They are constructed with a durable casing, and the casing is made of PVC, HDPE, or stainless steel to prevent collapse and contamination from surface runoff. The use of permanent monitoring wells also enables the installation of monitoring devices, such as, for instance, divers or passive samplers. And the filters can both be intersecting or not intersecting the groundwater table. So permanent monitoring wells intersecting, and I have to, it's coming later back as well, but I have to say that the guidelines or the I discuss here are, of course, the ones used in Flanders. So in Flanders, groundwater sampling regarding chemical analysis is not allowed when you have installed permanent monitoring wells with intersecting filters. So here you see that the groundwater table, the water level, is intersecting the screen of the filter screen of the monitoring well. This type of monitoring wells are only used to approve for the detection of floating layers and the performance of oil recovery tests. So when you install a monitoring well with a filter intersecting the groundwater table, of course, you have to take into account the natural fluctuations of the groundwater. So it's stated in our rules, in our guidelines, that the water column must be at least filling 50% of the filter length, even at the lowest groundwater level. At higher groundwater levels, then at least 10% of the filter must be clear, allowing the detection of, for instance, floating layers. Decision for installment of this kind of monitoring wells, they are based on the results of field measurements of, for instance, oil water testing and oil red tests, and also, of course, if already available analytical data. Here you see some pictures of a temporary monitoring well. Temporary monitoring wells, they are installed with probing techniques, and they can be used for short-term groundwater monitoring, especially in case of rapid sampling at different depths is required. So a hollow stainless steel probe containing an internal filter element is pushing into the ground using hydraulic or pneumatic force. So, and in this case, a narrow borehole is created. At the moment that when the temporary well reaches the required depth, then the probe rods are retrieved. So and in this case, the field screen comes available, and sampling of groundwater is possible. Although it's not used that much, it's allowed, but it's never allowed to use temporarily monitoring wells to drill through the presence of aquitars of impermeable layers. And of course, the boreholes have to be sealed afterwards. So here's a bit of wrap up of the use of monitoring wells with intersecting filter or non-intersecting filter. So a monitoring well intersecting the groundwater table, well A, can only be used for water leveling, LNAPL detection, or soil recovery tests. A groundwater well with a non-intersecting filter, the water level is above the filter screen, can be used for water leveling, but also for chemical analysis. It's not allowed to install groundwater monitoring wells with filter segments over different lithologies, and mainly those different lithological layers. To take groundwater samples at different depths, different well designs are possible. And here a distinction is made between a multi-level system, nested wells, and well clusters. Multi-level wells are installed in one single borehole and consist of a single tube with several isolated sample ports at different depths. To prevent cross-contamination, packers are foreseen in between the sample ports. The ports may have tubes or specialized access points extending to the surface for each sampling depth. And here you have seen a picture from above. So you have all these ports to the different filters or sampling ports of a multi-level well. Multi-level wells, however, are complex to install, complex with respect to maintenance, and there is a limited access to lowering down sampling equipment, and effective sealing of the different ports is not guaranteed. Nested wells correspond to multiple, here we have 3 individual monitoring wells in one single borehole, which each a filter depth as a specific a filter screen at a specific depth interval. To prevent vertical flow or contamination between the different wells, between the different filters. Also, a clay layer or a capping seal is installed, typically made by bentonite clay or grout. But as for the multi-level system, nested wells are difficult to install. Cross-contamination, there's always a risk of cross-contamination and also of vertical flow. It's very difficult to evaluate whether the different seals are functioning well. So therefore, with respect to the Flemish regulation, preference is given to the use of well clusters. So hereby, individual wells, as indicated here also on the picture, are installed near each other, but with each monitoring well installed in a single borehole, targeting a different depth for groundwater sampling. Compared to multi-level and nested wells, the installation is less complex and there exists a lower risk for cross-contamination. So if there are questions, please let me know because I don't see hands showing up. If there are no questions about the installation of monitoring wells, I will go further to the design of the sampling strategy.
I'll ask a question, Elsie, if you don't mind. So if I understood this right, to collect a groundwater sample, you have to install some sort of a probe and just collect the sample, and then the well is removed?
No, you leave the well, you leave only if you have a temporary well, then you remove the well. But if you install a well for long time monitoring, you leave it there.
You leave it there, but you're not allowed to sample that. So you couldn't install a long-term monitoring well and say, sample it seasonally in the Flemish regulation.
Yes, you can.
Oh, okay, you can. Okay.
Yeah. So I'm sorry if I didn't mention a permanent, or it's called a permanent, but of course it's not permanent for decades. But a permanent well, you can go over or you can go to it and sample it several times. That's no problem. It's only a temporary well. You install it, you retrieve it afterwards, and that's just for one single measurement.
Gotcha. Okay. For some reason, I got confused there. Thanks.
Okay. No problem. Perhaps I didn't explain it well. So, okay. So the design of the sampling strategy. So the sampling strategy is a function of the research objectives and includes the determination of the locations for the installation of the monitoring wells, the depth of the filter screens, the monitoring frequency, and the target parameters. So key elements, and here it's indicated, the monitoring frequency can be monthly, seasonally, annually, whatever you want. So, and key elements in the enrollment of a monitoring network are the required type of a monitoring well. So permanent with intersecting screen, with non-intersecting screen, temporary monitoring well. Its technical aspects. What's the depth of the groundwater table? Which filter length do we need? What about the installation of a clay cap, a seal, the filter pack, depth and length? And what's the sampling technique or the method we are going to use? I will come back to it later on. So are we going to use active sampling, or are we going to apply passive samplers, and how many samplers do we need? Of course, it's very important to install wells and to perform groundwater sampling in accordance with current procedures and guidelines. So if the same message I give with respect to soil sampling, of course, the field is not the same as lab surroundings. So if it's not possible due to location-specific characteristics or due to weather circumstances, and you cannot follow certain guidelines, no problem. Reflect about it, adjust it according to the field field characteristics, but very important, report when you cannot follow guidelines, procedures, what you have done instead, and what's the outcome of some changes. So when the objective of the groundwater sampling campaign consists of the characterization of the overall water quality of an aquifer, grid sampling or stratified random sampling in combination with grid sampling can be applied. And here, okay, it's for a big region, it's for Flanders, but here you see the spreading of a network, a monitoring network of temporary wells in order to characterize the quality, the overall water quality of an aquifer. So in this case, when we want to know the quality, then chemical analysis are needed. So therefore, we have to work with non-intersecting monitoring wells. Filter length can be several meters, a bit depending on location-specific characteristics and characteristics of the aquifers we want to characterize. Of course, monitoring wells can be installed with filters at different depth. And in this case, we want to know average concentrations, and therefore we will use high flow groundwater sampling. I will come back later to the difference between high flow and low flow groundwater sampling. With respect to the delineation of groundwater plume in contaminant research, multiple transect sampling with targeted sampling will be conducted. So here also groundwater monitoring wells with non-intersecting screenings, with non-intersecting filters must be installed. In this case, the filter length is limited, but because we want to have targeted water samples to 1 to 2 meters, and the filters have to be installed in the same lithology. The location where we will install the monitoring wells, they will be guided by the results of the soil sampling and also as a function of the groundwater flow direction. So here we have an indication at the side from the groundwater flow, and the monitoring wells are in fact installed in transects crossing these groundwater flow direction. When we want to get analytical results to delineate groundwater plume, we will use low flow groundwater sampling. When we want to indicate the presence of pure product and or to perform monitoring wells, in this case, a limited number of monitoring wells with intersecting filters can be installed. The length of the filter in this case is function of the thickness or the expected thickness of the smear zone. So, and to recap, we have seen this definition when talking about soil sampling, but the smear zone refers to the layer of soil that has been contaminated by LNAPL due to fluctuating groundwater levels. Knowledge of the extent of the smear zone or the pure product zone is crucial with respect to remediation. So, and as long as pure product is present, delivery of mineral or contaminants to groundwater occur. Therefore, it's very important to get a detailed characterization of pure product zones, not only by soil sampling, but also by the use of monitoring wells with intersecting filter screens. So how do we install, or what are elements important or you have to take into account when install monitoring wells? At first, very important, avoid contact between the monitoring well, contaminated soil, or contaminated materials like objects, pavements, and so on. And of course, it's perhaps obvious, but we see it from time to time, do not install dirty or contaminated tubes. As already indicated, where do we install the filter? The filter needs to be installed in the aquifer and on the depth that needs to be sampled or monitored. The minimal diameter of the monitoring well is function of the monitoring equipment that you want to use and of a pump type. Of course, monitoring wells need to be sealed off at the surface to protect the wells from influence from the surface, like for instance, rainwater or wastewater. But also at the bottom, a cap need to be installed to prevent the inflow of soil material into the filter segment. This is less obvious in let's say, more clayey soils, but especially in sandy soils, don't forget to install these caps. Okay, we have our borehole. We have installed the monitoring well, but of course we have to backfill the annular space, and we have to backfill it or let's say to see that there is no vertical flow present in or near the monitoring well. Around the filter, a filter pack is, so a coarse-grained filter pack is installed with calcined, sieved, and calibrated sand or gravel. And this so-called filter pack must be installed at least 25 centimeter or 50 centimeter above the filter screen. And of course, this is important to let the groundwater flow into the filter segment. On top of the filter pack, a sealing bentonite plug should be provided. And also on top or just below the surface, also a bentonite plug have to be installed, and it's not the case in this figure. Of course, when a pure product zone is present, also sealing bentonite plugs have to be installed where you cross a zone where possible pure product is present. When you have to seal the presence of impermeable layers or pure product layers, then of course the minimal thickness of the bentonite plug is given by the thickness of the impermeable layer and the thickness of the pure product zone. What do you need to install the sealing plugs? You need bentonite pellets or grout, and grout is a more liquid bentonite or product that you can use to install impermeable plugs. For filling the remaining part, let's say here, this part, or in between these bentonite seals, you can use the original soil that came above ground when conducting the drilling, if not contaminated. In that case, backfilling has to be done according to the lithological sequence of the bore profile. Of course, also clean sand can be used for backfilling as well. To install a monitoring well, it's very important to know the correct layout. So you need to know from your client or from the project manager which diameter of borehole you have to use or drilling you have to use. You need to know beforehand at which depth you have to install the filter and which filter length are required. You have to need to know in advance or where you have to position the bentonite seals and the position of the grind pack. At the bottom here, this is the so-called sludge trap, and this is also about 50 centimeters when you install monitoring wells for long time monitoring or for a longer period of groundwater monitoring. After installing the monitoring well on the field, it's very important to add a correct label to each of the installed monitoring wells. These labels must contain a unique ID, the date of installation, the filter interval, and also a qualitative indication of the groundwater flow. Is it good, moderate, or bad? Since the installation of a monitoring well results in the disturbance of the soil profile and the water flow, monitoring wells must be developed afterwards. So the terminology monitoring well development includes all operations aimed at restoring natural hydraulic characteristics of sediments, follow drilling with completion of the boreholes to a monitoring well. Monitoring well development includes at least flushing the monitoring well right after installation of the well. So this must be done gradually with high pumping flows of flows more than 500 milliliter per minute and up and down movement of the pumping tube. You have to refresh at least 5 times the water column, and this means the water volume present in the blind tube and in the filter segment. And as said, high flows are required to clear or to develop the monitoring well. When working water had to be applied during drilling, then 5 times the volume applied must be refreshed on top of the volume related to the water column. After monitoring well installment and the immediate redevelopment, you have to wait at least 7 days before you can go back on the field with respect to groundwater sampling. Here, probably I already discussed some parts in the session concerning the soil sampling. So when you're going to install monitoring wells in pure product zones, like LNAPL and DNAPL zones, you cannot use every type of borehole. And very important is that you make use of casings. So you can permitted drilling techniques are manual drillings with lost casings, or the use of core samplers and balers with a casing. When installing or drilling in general through a pure product zone, then the use of a spiral auger is not permitted, and also the use of working water is not permitted. With respect to the installation of monitoring wells in pure product zone, you also can't install nested monitoring wells. You only can install single or monitoring wells in a single borehole. Perhaps you have some questions about the terminology of additional water, or sometimes I call it working water. I don't know whether it's the correct English terminology. But within this respect, I will give some words regarding drilling liquid or drilling mud. So the use of drilling liquid or drilling mud is mainly related to mechanical drillings and the installation of monitoring wells. Drilling liquid or drilling mud refer to a fluid used in the drilling process of boreholes. It's used because it's sometimes a critical component in drilling operations. It has several functions to ensure efficient and safe drilling. Drilling muds can be water-based, oil-based, or synthetic-based. and are tailored typically to the specific needs of the formation being drilled. For drillings that are not installed that deep, or especially also in sediments, it's not that common. In any way, drilling muds are prohibited in case of environmental. The use of drilling muds is prohibited in case of environmental research. If the use of a drilling liquid is technically necessary due to terrain conditions at which no other drilling method can be applied, then the application of additional water is allowed with respect to environmental research. What are then the requirements? Water must be of good quality, equivalent to drinking water quality. You have to report the use of additional water, indicating the volume and the water added to the borehole. After installation of the monitor well, I just said it some slides ago, then you have to remove the proportional volume of the additional water used during the installation of the monitoring well. What you have to do with the collected water afterwards, you have to collect it in a container, in a cubitainer for treatment afterwards, or if a water treatment plant is in the neighborhood, you can discharge the additional water that has pumped up when redevelopment the monitoring well in the water treatment plant. So, and we are still not sampling groundwater. We have installed the monitoring well. We developed the monitoring well, but as an element that is important to measure is the depth of the water level, the depth of the groundwater table. So groundwater levels must be measured relative to a fixed point, such as the top of the well tubing or the surface level. And it's important that you are consequent, that for a certain field that the one monitoring well measured to the top of the the water level measured to the top of the well, and at another location that you measure the groundwater level to the surface level. So be consequent, use always the same fixed point for all monitoring wells. Especially when several monitoring campaigns are foreseen, or if you have to compare data from different neighboring parcels or plots, then it's better to measure the water level with respect to a reference value. And in Belgium, the reference value is relative to sea level, and it's called meter TRE. In this case, the measurements are carried out by a land surveyor. What can be used to measure groundwater levels? We can use measuring devices such as tapes, what's illustrated in these figures, which have an audio or a visible signal. So from the moment that the tape reaches the groundwater, you will hear it or you will see it, and you can write it down. So important, correctly report water level measurements, or to the top of the monitoring well, or to the surface level, or relative to a fixed point, so that you are able to compare the different measurements with each other. So how to determine then the groundwater flow direction? Groundwater flow directions can be estimated based on topographic maps, as you can see here. So in general, the water flows from the highest point downhill in the direction of discharge points. Of course, it can also be done according to the principle of the hydraulic triangle. In this case, you have to install at least 3 monitoring wells. You measure the groundwater level, and then subsequently you mark the levels on a map and draw equipotential lines, so lines with the same water level, and then the groundwater flows in the direction perpendicular to these equipotential lines. Why is it important to determine the groundwater flow direction? Of course, it's important when you want to delineate a groundwater plume. So I have already mentioned several terminologies, and one of these terminologies was the difference between active and passive sampling. So what is active sampling? Sorry, active sampling results in a snapshot of the water composition at a certain time and at a certain place. So active sampling corresponds to a forced extraction of the groundwater. So, and hereby the influence of the zone where groundwater is extracted is not known. Active sampling may also result in emptying poor yielding monitoring wells. It reflects fluctuations in concentrations, and you can have, especially when pumping at high flow rates, you have risks of volatilization. Passive sampling, then you don't use or you don't include forced extraction of groundwater. When you go over to the execution of passive sampling, you deploy a passive sampler in a monitoring well, and depending on the type of the sampler, you can get instantaneous concentration measurements, time integrated concentration measurements, and mass flux determination. And passive sampling will be part 3 or 4 of this presentation, so I will come back later to it. So when you choose for active sampling, then you have a distinction between high flow sampling and low flow sampling. High flow sampling, also called volume-based sampling, is applied when the overall status of the groundwater body or the aquifer has to be determined. High flows are used for rinsing the monitoring well. So flows of above 500 milliliters per minute are used. In this case, the groundwater is extracted around the filter over a quite large area. Low flow sampling or micropurging is used to identify potential contamination and to delineate groundwater plumes. Water flows for both rinsing the monitoring well and groundwater sampling are below 500 milliliters per minute, and they correspond to a groundwater extraction over a smaller area compared to high flow sampling. And that was what was illustrated in this figure. So here, high flow sampling, the influenced area around the filter screen is much bigger compared when you use low flow sampling. Okay, these were some conceptual parts of groundwater sampling. I don't know whether there are questions about it.
I don't see anything in the chat. I don't have any questions. Would now be a good time to take a short break? It's been about an hour. We could just do 5 minutes.
Yeah.
Let's let everybody go to the washroom, grab a glass of water, and we'll be back at 10 after the hour. Okay?
Okay, great.
I'm back. How do you think we're doing for time? Elsie, do you think we're going to make it for the next 20 minutes, or what's the plan?
I'm afraid, but I will skip. I still have quite a lot of slides. So,
quite a lot of material. I'm just trying. Is Christoph still on the line? I'm just going to look at the calendar and see what we can do. Friday is just electrical conductivity, and you don't have any more presentations, do you? Oh, Christoph is there. Nice.
Yeah. No, indeed, you're right. That can be an idea if needed, or unless, Ilse, you said maybe an extra 10 or 15 minutes. I think it's feasible as well for today. We announced that it would take longer in advance, so
Yeah,
But
we
of
will
course, I
see.
would not go if it's any further than that. Maybe it's better, like Nathan said, to have something else. But
Okay.
I would say maybe maximum, let's say 40 minutes from now on, if that's feasible, Ilse, for you.
Yeah, but stop me where stop me if because I have a lot of slides to go on. So just I will try to finish the groundwater sampling. Yeah. So if we cannot tackle passive sampling or divers and or recovery tests.
Yeah.
Okay.
And otherwise, I think I understood the next session on Friday on electrical conductivity. Maybe only 1 hour or just a little bit more. So maybe we have there then some 25 or maybe half an hour also. But I don't know if you are available then. So, but
It
that's another
depends
opportunity.
if it's before noon or afternoon. Because
It's in
before
before
noon,
noon. It's
then
before
I'm
noon.
in Mechelen.
Oh,
So I'm
okay.
not there.
Okay.
Okay.
Well,
we'll see how we manage that.
Well, we'll try our best on this one. I think if we get through the low flow, I know the passive sampling and diver sampling is somewhat less common. So we have to, let's just go for it and we'll see where we get and we can make that decision at the end here.
Okay.
And don't speak too fast, Ilse.
Am I going too fast?
No. But
No.
if you want to compensate your slides, I mean, just don't go too fast for the translators. That's what I wanted to say.
I know. Okay. Okay. So in part 2, we will have a look at to the good practices and pitfalls in conventional groundwater samplings. So here again, it's important to notice that the guidelines mentioned are in line with the Flemish procedure regarding groundwater sampling. At first, it's necessary to select pumps that can meet the technical requirements of the monitoring wells to be sampled, such as the depth, the diameter, the groundwater level, the presence of volatile organic carbons, the risk of contamination, of cross-contamination. So secondly, go for pumps that result in minimal disturbance of the groundwater. So avoid turbulence, or especially when volatile organic carbons are present, and also avoid cross-contamination, as just said. So, and within this respect, select pumps for which the elements that are in contact with groundwater are made from inert materials that can be decontaminated or that can be replaced. Of course, your mouth is not or cannot be used as a pump. So because of the time frame, I will skip the description of possible pumps, and I will go immediately to the overview table. So the rest, I think you can read at home, and if questions, you can ask them during the practical sessions. So as for soil sampling, a table with an overview of available pumping devices is given. So this list is not limitative, but it describes the suitability of different sampling equipment, different pumps, in relation to the refreshment of the well, of the water column, in relation to groundwater sampling, and in relation to the required minimal diameter of the well. Important factors on which your choice depends are, for instance, the depth of the groundwater table, the possibility to decontaminate elements of the pump being in contact with the groundwater, the risk for cross-contamination, the risk for turbulence and thus aeration of the groundwater, and the parameters to be analyzed. So if you want to select the pump not being on this list, no problem, but evaluate in advance if its use is according to the elements which are mentioned here. And according to this table, the use or centrifugal submersible pumps, foot valves, or peristaltic pumps are proposed with respect to groundwater sampling. What are the next steps? You have installed the monitoring well, of course, or you are going to use an existing monitoring well. In advance, you have to contact the lab so that you can take the correct recipients with you to the field. Check also if preservatives must be added to the recipient before sampling, which in fact has to be avoided on the field. Check always the condition of the monitoring well. Measure groundwater level before and after sampling. Measure or check the presence of free pure product. Measure always the well characteristics like depth. Why is that important? Then you can evaluate whether there is too much sediment in the filter, and also the diameter of the well. Pre-pump and refresh the groundwater before taking the sample, and carry out on-site measurements. In Flanders, it's obliged whenever you go to take a groundwater sample, you have to measure on-site pH, conductivity, and temperature. Additional parameters are the dissolved oxygen, redox potential, and turbidity. Check also the type of sampling, what's required, high flow, low flow, or do you have to install passive samplers, and is there a need for on-site filtration of the groundwater with respect to the target parameters. So here, I mentioned it already, low flow and high flow. What's the principle of low flow sampling? So the principle of low flow sampling involves the extraction of water, both during the refreshment of the water column and sampling at a slow rate, especially between 100 and 500 milliliters per minute, or even less than 200 milliliters per minute when you have wells with intersecting filters. And this is to maintain stable groundwater levels during sampling, and thus to minimize the influence of water extracted from other depths. So this technique, the technique of low flow sampling, aims to retrieve samples that more accurately represent the in situ groundwater chemistry near the filter of the well. When you are going to perform low flow sampling, during the sampling, the drop of the water level must be measured all the time. When can you stop with pre-pumping? Then it depends on this, if you achieve stability of the field measurements. So you can stop or end the pre-pumping if you reach stability for the conductivity and or in combination with the removal of 5 times the water volume of the filter element. You can also end pre-pumping when you reach stability of the conductivity measurements and of the dissolved oxygen, or when the value of the turbidity is less than 10 NTU. If none of the above criteria are possible to reach, then you have to remove 3 times the volume of the groundwater well. That means the water column, 3 times the water column present in the filter and in the blind tube. So I mentioned it already, field measurements. What are the requirements of the field or of meeting the stability? I don't know, Christophe, whether it was mentioned during the lab session, so then I can skip it. If not, I just go through it.
I think this will be mentioned in the lab session, so you can go through it, yeah.
Okay. The only thing what's important, so at the field, you have to measure at least 5 times the field criteria. And when you need stability, you must reach it during at least the last 3 measurements. And between 2 measurements, you have to at least the volume of the flow through cell, and you have and the pumping tubes must be flushed. So perhaps I go back here on the right side. You see the flow through cell, which is used to carry out the field measurements. And here you see the different different probes in the flow through cell. Oxido reduction potential, I'm also skipping it because it's probably also tackled in the lab sessions. What about then filtration? So as already mentioned, it's important that you check before if you need to sample the groundwater, to filter groundwater on the field. It's obliged when your target parameters include metals or cyanides. In that case, you have to filter on the field. Hereby, it's preferred to use a filter. It's indicated here on the picture, a filter that is placed in series between the recipient, and here you have the tubing of the pump, so that is in place between the monitoring well and the recipient. While filtering, always avoid the inlet of air. So what are additional general guidelines with respect to groundwater flow monitoring? With respect to groundwater sampling. So if information of the pollution is given or is available at the start of the sampling campaign, then you have to take the samples from the less polluted monitoring well to the most polluted well. Of course, sample tubings need to be replaced before each sample. So you cannot reuse sample tubings from one groundwater well into another. Wear a fresh pair of gloves for each well. When you fill the recipients, fill them in a single go without getting air bubbles. Topping up recipients for volatile parameters is prohibited. Important to mention also, you will have recipients that you have to fill with no preservatives, some with solid preservatives and others with fluid preservatives. When you overfill a recipient that contains a preservative, you have to start again with a new preservative. Of course, it's also very important that you replace or clean, decontaminate all the tubes and parts of the pumps that have been in contact with the groundwater. Respect the filling order. First, start with filling the recipients with no preservatives, followed by the recipients with a solid preservative, like for instance, ascorbic acid, and then finally fill the recipients with fluid preservatives. During filling of the recipient, I think I already mentioned it, but avoid turbulence. So for low flow sampling, preferably the flow rate is even lower as the flow rate used for rinsing the monitoring well. For the intersecting filter, a flow rate is foreseen of about 100 milliliter per minute. For monitoring wells with a non-intersecting filter, a flow rate of about 100 to 200 milliliter per minute has to be maintained. Keep the recipient straight. And when you start with filling of the recipient, the tubing is quiet. You bring it deeper in the recipient, and then you bring it up while the recipient fills. Recipients with conservatives, after sampling, you have to cut off the part of the tubing that was in contact with the sample. Okay, what's then about high flow sampling? So what's the difference between high flow sampling and low flow sampling is mainly related to the high flow applied during the refreshment of the water column prior to the sampling. So during pre-pumping, at least 5 times the water volume of the monitoring well is rinsed, and this has high flow rates, and high flow rates are rates about 500 milliliter per minute. At that moment, you extract groundwater from a bigger area around the filter segment. The moment that you are changing to the sampling itself, then you can use low flow, thus avoiding turbulence. When applying high flow sampling, you have to refresh minimal 5 times the water volume of the overall monitoring well of both the filter segment and the blind tube. You have to reach stable field parameters, and of course, as already mentioned, you can use high flows for the pre-pumping. Important to mention, when applying high flow sampling, it's applied for, let's say, the characterization of the quality of an overall aquifer. So you will get average concentrations. You also get large volumes of wastewater, where low flow sampling will result in lower volumes of wastewater. If you sample for PFAS, the same when you are going out for soil sampling, you have some extra precautions. So if PFAS is a target parameter, extra guidelines are in place. So as far as possible, you should check with the supplier or on the basis of analysis whether the material you used for groundwater sampling may contain PFAS or not. So any direct contact with a sample must be avoided, including direct contacts with the gloves. And for the rest, the same guidelines are in place as for soil sampling. Also, with respect to groundwater sampling, a field report is very important. What do you have to add? Of course, the date of the groundwater sampling, the identification of the research area, the identification of the field workers. You have to identify the monitoring well numbers and the filter depths, the type of the monitoring well you sampled. Are they permanent, temporary? Do they have intersecting filter or non-intersecting filter? What type of pump did you use? Is there a presence of a sand or silt trap? When did you start pumping and end pumping for both the refreshment and the sampling itself? And what is the flow rate you maintained during pumping and during pre-pumping and during sampling? Also, the volume of the groundwater pumped up, you have to report what's the depth of the groundwater before the start of the pumping and after the sampling. Are there any organoleptic observations? Like, do you have special colors effects? Is there a passive odor? Can you say something about brightness and so on? Of course, you have to report the field measurement values. If applicable, you also have to mention the volume of working water that has to be removed. You have to indicate depth and thickness of pure product, if present, and you have also to indicate what you did with afterwards with respect to the groundwater you pumped up. As indicated before, non-conformities with respect to the requirements, with respect to the guidelines, have to include it. So you have to indicate what went wrong or what was not in order with the several guidelines. If there are wells that are damaged, you have to describe it. You have to describe the condition of the monitoring wells and so on. If sampling is carried out in existing monitoring wells, yeah, an assessment must be made, of course. So, and what if you are going on the field? You have to sample a well that is damaged or completely clogged, so that in fact has to be taken out of service. So you have to decommission it. How do you do it? Of course, you have to remove all instruments from the monitoring well, the pumps, recordings, equipment, and so on. Normally, pumps you will not leave behind, but if there are divers in it and so on, you have to remove it. Yeah, remove the cap of the monitoring well, and if possible, retrieve the monitoring well completely out of the soil and try to fill the borehole according to the contamination status of the soil. So fill the borehole with grout from below if required by the contamination condition of the soil structure. If it's a location where there is no groundwater pollution present, then you can fill the borehole with gravel as long that you didn't pierce low permeable layers. If you cannot remove the well, most of the time it's not very easy to remove the well out of the soil. You have to cut off the monitoring well at least 10 centimeters below the surface level. You have to fill the monitoring well with grout, with clay, with impermeable layer. For monitoring wells up to 8 meters along the entire length. If you have to backfill deeper monitoring wells, you have to backfill at least 8 meters with the backfilling up to 4 meters above the filter with impermeable layer, and the remaining part can then be filled with uncontaminated soil. Of course, you have to finish the surface level according to the use of the site. And if the monitoring well has acted as a preferential path for spreading pollutant, then the monitoring well has to be drilled out. In this case, the complete borehole must be filled with impermeable material. And that is what you can see here. You have monitoring well that has been decommissioned. So here you see that grout is added to the monitoring well. I don't know whether you can see it, but here the part of the monitoring well what's above the ground is removed by sawing. And here again in the hole, grout is added. And at the end, yeah, the well is still there, but the ground will be leveled and restored according to the surrounding area. So, okay, I already went through it. I don't know whether there's still time to go through the application of passive samplers.
I think we can do about 10 more minutes if you want to.
Okay.
Yeah.
Okay. So what are passive samplers? Passive samplers are sampling techniques that allow to capture pollutants passively. So without energy supply from an external source, so without creating active transport of pollutants. Passive samplers are deployed to a desired depth within the filter of a monitoring well, and it's used for the identification and quantification of captured pollutants. And this is done by chemical analysis after the collection of the sample sampler or after subsampling in the field. And here I'm not going through all of them, but here is an overview of different passive samplers. Not all of them are already on the market, but anyway mentioned in literature. So in general, you have three different types of passive samplers. You have grab samplers, what are, in my opinion, not directly a good example of passive samplers. Then you have the diffusion equilibrium sampler and integrating kinetic samplers. So what are grab samplers? Grab samplers are used for instantaneous sampling. So you sample the groundwater at the desired depth. And examples are a snap sampler, hydrosleeve, discrete interval sampler, and so on. So these samples are just lowered down in the monitoring well, be there for a certain time, then retrieved, subsampled, and then the resulting sample is in fact comparable to conventional groundwater sampling. What are equilibrium-based samples, passive samplers? There you have a balance between the receiving phase, what's indicated here in the picture on the right-hand side, and the sampler, or the balance between the concentration in the receiving phase and in the groundwater. So the receiving phase is located behind a semi-permeable membrane and can consist of solvent or a demineralized water. So pollutant transport occurs through diffusion. And for an example of a passive sampler is a passive diffusion bag. It's the representative or the concentrations observed in the passive diffusion bag, for instance, are representative of the composition of the groundwater during the last days before retrieving the sample. Then you have kinetic passive samplers. There, the receiving phase is a chemical reagent or a porous adsorbent, and it's usually located behind a permeable casing or a porous partitioning element. There is no equilibrium between the groundwater and the receiving phase. So most of the time, the receiving phase is characterized by high absorption capacity, and you have continuous supply of pollutants. Within the kinetic passive samplers, there is a differentiation between diffusion-based or permeation-based passive kinetic samplers. Within diffusion-based passive kinetic samplers, the transport mechanism is diffusion. But there you get a time-integrated concentration, and examples of diffusion-based kinetic passive samplers are Gore modules or ceramic dosimeters. What are permeation-based kinetic passive samplers? Within these samplers, groundwater is the driving force with respect to advective transport of the pollutants. So the permeability of the casing and the adsorbent of these samplers is higher than the surrounding aquifers, and the result corresponds to time-integrated concentrations. Examples are the sorbet sample, passive flux meter, and also iFlux sampler is also an example of a permeation-based kinetic sampler. How do you select which sampler to use? That's function of the objective of the research, of the target parameters, of the technical specifications of the monitoring wells, of hydrogeological characteristics, and of location-specific conditions. A detailed overview of available passive samplers, together with the scope and the pros and cons of these samplers, is given in the next slides, or you can also go to the ITRC website, where you have an overview of several passive samplers. In case you want, or PFAS is a target parameter, you have to check with the provider whether passive sampler you want to apply contain PFAS or not. If it's contained PFAS, then of course you have to be sure that there is no leaching from the device possible. Okay, so I think I can skip them. You can go through it here. I have some examples of grab sampler. That's the Hydra sleeve, baler, a snap sampler, but snap sampler and Hydra sleeve we will illustrate in the practical session. Passive diffusion bag is an equilibrium sampler we will illustrate in the practical session. The Sorbicel is a permeation-based kinetic sampler, and then the iFlux sampler we will also show during the practical session. So what are then general guidelines? Do you need to refresh the water column when using passive samplers? Yeah, it's still necessary when you make use of grab samplers, unless you use a snap sampler when you have a long time exposure. In the other cases, you need to pre-pump or refresh the sampler before the deployment of the passive sampler. This is not the case when you use equilibrium or kinetically based samplers, unless the monitoring well is characterized by low flow conditions. Where do you install passive samplers? Always at the level of the filter screen and always fully submerged, so always completely surrounded by groundwater. So the application of passive samplers is not allowed in monitoring wells with intersecting filters. The exposure time is site specific, is function of concentrations, function of water flow, is also function of the sampler characteristics. With respect to kinetic passive samplers, exposure time is also determined by the characteristics of the adsorbent to be applied. And in fact, you have to have an ID in advance. So exposure time needs to be determined in advance, taking into account the order of the magnitude of the parameter, concentrations, and the groundwater flow velocity. Both deployment and retrieval is gradually, so you have to avoid disturbance of the groundwater column. You have to avoid the upwelling of sediment. And if by retrieving or even by deployment, but that you then know while retrieving, if the passive sampler is damaged, analysis don't make any sense and you have to throw them away. Another important element, sometimes passive sampler can be clogged because of biofouling, as you can see here. Of course, in that case, also analysis of the groundwater is not done. Subsampling, sometimes you have to do it on the field. Then you have to follow the same guidelines with respect to sampling or filling recipients when respect of the classical groundwater sampling. Labeling, of course, when it's not done in advance, you have to add the right label immediately after retrieving the passive sampler in the field, or when retrieving the subsample. Always apply unique ID, the date of deployment and the retrieval, and also indicate the depth of exposure. How do you have to store the samplers? Keep the recipients or the cartridges refrigerated immediately after sampling until delivery to the lab. Passive samplers, subsamplers should be stored in a cool and dark place. If there are specific requirements, then you have to ask for information from the vendor. If you are going to deploy passive samplers in existing monitoring wells, you have to know the technical data, you have to verify the filter depth and the diameter of the monitoring well in advance. And another important note is when some of the passive samplers, they have also a cartridge or sampler expiry date. If the expiry date is exceeded, of course, this type of sampler or cartridges cannot be used anymore. The field report, additionally to the field report of groundwater sampling, of course, mention the exposure time of the samplers, the date of installment, the retrieval date, the depth of deployment. Do you need pre-pumping of yes? Please indicate start and end time if done, the type of the pump, the flow rate used, and the volume of the groundwater pumped up. Also in this case, add or report organoleptic observations, field parameters if applicable, and also, of course, any deviations from procedures of guidelines. So that's it with respect to the passive samplers. I don't know whether there are questions.
No, thanks, Elsie. That was good. You just gave me flashbacks to getting sunburnt, sitting on a cooler, some gas station parking lot in a remote Canadian village. It's been a while, but done quite a bit of low flow sampling in my time.
Yeah, okay.
Anybody else have any questions for Elsie and anything to do with the sampling? I know it seems quite complicated in theory, but I think it's one of those things where practically when you get out there and handle the tools and start pumping and taking measurements, it makes a little bit more sense. So hopefully the practical portion is a bit more helpful and easier to digest. All right, so if there's no questions, that's it for today. So we'll see everybody again on Friday to go over the analysis of electrical conductivity in the lab. I think that will be at 10 o'clock a.m. Belgium time and 11 o'clock a.m. Ukrainian time, if I have that correct. So thank you, everybody, and thanks, Elsie, for taking the time to send that all to us.